Alright, let's get started with our first Android lesson. And this is lesson number 1, lecture number 1. And I promise you the entire course is not going to be PowerPoint. In fact, just today is pretty much all of our PowerPoint. Today's lecture is going to be kind of short, actually, unless I'm long-winded. But it's going to introduce to you the Android application development environment and a little bit about the tutorial-driven course format that I've kind of put together for this particular term. And what I mean by tutorial-driven courses is instead of looking at PowerPoint for the entire course, what I'm going to do is go through projects, which is why during the introduction part of this lecture I said if you have your tool set installed, if it's on your notebook computer, bring your computer to class. If you do that, then you can download and I'll make available through zip files on bhacker.com or even maybe just through YouTube. I'll make available the project files so you can download them, install them, and starting next week, actually, we're going to be doing that. So I'll be running through different, a dozen or so different applications or so. Also, if you haven't heard, just a slight announcement before I forget to make it, on March 31st at ITU here, I'm going to be doing a Android workshop. I'm going to call it a workshop. You don't have to be enrolled in the course. You don't have to. In fact, if you have friends, there's no money. It's free, absolutely free. If you have friends, if you know anyone who wants to show up, it's going to start like around, I don't know, I'll have the times as we get closer, but it'll be like about 8 hours or so. It's going to start in the morning and go all the way through the day. And in that particular workshop, I'm going to spend the morning hours going over the install and the platform itself, and building small applications, hello world, stuff like that, little I/O stuff. In the afternoon, and right after the lunch break, essentially, I'm going to run through 3 sample apps. Well, I'll give you the code for it as well. One of them is going to be using a mapping, so it'll be a mapping map, Google Maps. The other one's going to use the database, and the third one, I'm thinking maybe an SMS application, like a little app that does like some fancy pre-written text messages and stuff like that. So that's always fun. When you get lazy, just select from a menu. Hi, how are you? How you been? So it's a nice little app. Kind of. But I will have more information on that as we get closer. But that will be on March 31st. It will be on a Saturday, and it's because ITU is trying to launch a certificate program in Android application development, and actually you guys who are taking the class can apply that class towards the certificate program as well if you want. It's not just Android, however, it's for mobile phone applications, so it includes iPhone, Android, tablet type development classes. So there's an Objective-C course, a Java course, this class, and as well as the iPhone class are part of the certificate program. I believe it's only 4 classes total. You do that, and then you're supposed to get this graduate level certificate, and they're launching it to the local market, so they're trying to get people to come in to check out ITU, check out mobile phone application development. So it'll be free. So if you're bored, you're in the area, stop on by. I'll have more information as we get closer. But nice way to kind of refresh your skills too if you're taking the class, because I'll be introducing some stuff that I'm not going to be introducing in this class. So, but maybe I will. Who knows? Anyway, so let's talk about Java for a second. Get back on target with our lecture. First lecture, I didn't get too far before I got off on a tangent. Alright, so Java, basic Java programming. Well, okay, so the Android platform itself, as I mentioned already in my little introduction, it is all Java based. So we're looking at exceptions, inner classes, and interfaces. In terms of advanced topics that we're going to touch upon, a little bit of the I/O, a little bit of threads, a little bit of socket stuff. And all this stuff can actually be used in terms of, in fact, thread programming is kind of interesting as a concept. The Android phone is a multi-threaded platform. In fact, it's a Unix-based platform. So, long story short, you can have multiple threads of execution happening simultaneously. You have different, I'm going to use these quote-unquote services going on in terms of functionality. And it's happening simultaneously, which is something that we'll look at in terms of the course itself. So the credit goes to Google. In fact, these are the Google slide sets that was used at one of the summits that happened probably about a year ago at this point. But Android itself, you can thank Google for it. So I'll never say anything bad about Google. So I will talk about Microsoft in a negative light, but never Google. Never Google. Google's a nice company. All right, course objectives. This is what we're going over today. And in fact, this beginning introduction is nothing more than an introduction to the course. So, because on the first day of class, nobody's got the platform installed. It makes no sense to talk about Java. It makes no sense to talk about Android when you can't see it and can't do it and have no idea what I'm talking about. So that's why I say go home, install your tool set, bring your computer next week, and we'll be talking about how to program and how to create apps and stuff like that. So, mobile application development. No one actually uses this acronym anymore either. MAD. Kind of because it sounds mad. It sounds like offensive or something. But for a while, I saw this all over the place, and then it went away. It's kind of like a stupid acronym, I think. But mobile application development. So as a concept and in terms of the course objective, one of the topics that I'll be discussing in this course are different platforms for mobile application development, which goes beyond the phone. So as I said in the introduction, Galaxy tabs and tablets in general would fit into this category. You don't actually have to have a phone. I will also be providing an introduction to the Google platform. This is going to happen next week as well as today. Actually, I'll talk about the platform and the framework a little bit before I end. And the platform architecture as well, because we'll be using the architecture, so it's not a bad idea to be familiar with the different components in terms of the pieces that fit into the framework. Application building blocks, development tools. The textbook, as I mentioned before in the syllabus, is Hello Android. It is optional. It is not required. So don't feel obligated to go out and purchase it. In fact, you could probably find, and I have an old version of it, but you could probably find an old version, or actually I think there's only one version of it, original version of it used on the internet. If you'd like, I actually have a version of it that I'll loan out. In fact, if I dig around, I might have even more than one version of it. In fact, I believe the library's got a couple of copies of it too. So it's the same book that I used the last time that I taught this course. A few reasons to go mad. That's mobile application development, so a few reasons to go mad. Smartphones are everywhere. You can't deny that. Internet access is anywhere and everywhere. Can't deny that. Social networking is everywhere and anywhere. Can't deny that. So it'd be nice to be able to do some application development work that took advantage of all of those different things. So I think that's why mobile application, or MAD, has become so popular, because it's most of our applications that we're using today. Who turns on your Windows box and uses something that doesn't connect to the internet? Or doesn't involve any type of social networking or have anything to do with modern day technology? Nobody. So even our desktop computers are now just elaborate, huge phones, if you think about it. We have widgets and applications and things. But what are we doing? We're connecting to the internet. So, which is why I think the tablet concept, not to go off on too far of a tangent here, but why I think the tablet concept is fantastic. It's because it's the hybrid. It's not a phone and it's not a computer. It's like right in the middle, So you can still type letters and stuff on the tablet and respond to email, but you don't have to carry around a notebook computer with you. It's not a computer. So anyway, millions of mobile users, yes, and it's an open standard, which is another good selling point regarding the platform. So let me talk about the Android in particular, which is part of the MAD system here. So open software platform for mobile development, yes. In fact, when you install the APIs, you'll see a lot more than just different Android different phones. You'll see the different platforms. You'll see the different framework components as well. And it'll become more obvious to you the more we work with it in terms of application development. There's a complete stack. There's an operating system, a middleware, and there's applications. So essentially, the Android platform, believe it or not, is an operating system plus applications plus networking support. It's actually, in terms of phone or small mobile device platforms, the Android is, believe it or not, the most sophisticated. This is my selling point now. The most sophisticated platform I've seen, actually, in terms of full functionality. For a while, we had Java-based, well, we still have it, BlackBerry phones, or I can't remember the name of the platform right now, but where it was, you built applications in Java, but you don't really actually have like a full operating system. When it did thread programming, when it did internet work, data, cellular services, and an entire framework that was involved with it. So Android is as we've become through the history of programming, the history of application development environments, it's not bad. It's pretty sophisticated in terms of what we've got available these days. It's an open handset alliance project. It's part of the OHA project, powered by Linux operating system, as I mentioned in my little introduction we had before this. Linux-based platform. So it's kind of interesting, although primarily programming in Java, fast application development in Java, open source under the Apache 2 license as well. So if you're familiar with Apache, it's a server type of component, you'll see. And I really like this slide here, actually. And as I mentioned before, this comes from the Google presentation materials that were done at one of the Google Summits for Android a couple years ago, actually. In fact, this is the base application layer, or what you call operating system layers that exist, and this is still relevant, even though this was done a couple years ago. We're still working with the same platform. There's been some enhancements to it in terms of improvements of some of the architectural pieces, but the architecture itself hasn't changed from the beginning. And what you're looking at is a picture of the operating system. So if there were an operating systems course, I'd start here on the bottom, and I'd say, first we have the kernel. Well, this is the Linux operating system. So naturally on the bottom, we've got our kernel layer. And the abstraction of this layering is important to keep in mind, because these are the features that we're going to be using up here on the top. So in this particular class, we'll be writing applications that we're going to be running that are going to fit and work with contacts and the browser and other different components of other applications, but it's really running on this framework, starting at the bottom in terms of the kernel level. And I'll spend a few minutes just kind of going through why this is layered this way in terms of the architecture, and this is kind of a repeat of what you've had in Linux and operating systems fundamental courses. But if you keep everything at a kernel level, then you've got control and you've got protection of the certain driver bases, which kind of protects, if you think about the differences between the application layer and the kernel layer, if we had more protection in a Windows operating system, we wouldn't have any viruses, we wouldn't have any problems, we would essentially be running faster, I think. We would definitely be able to have more features and more intermixed components rather than having everything built together in terms of a single, fewer layers. You've got more exposure to problems, to infiltration of issues. But if we have a protective Linux kernel and you can't get to any of this stuff down here, if it's hidden within inside of the operating system, not available the application layer or anything else above it, or in between it, then you've got power management, audio drivers, your basic functionality that can't be messed with. You can never mess that up, I should say. And the kernel is going to be responsible for the major hardware components. So the kernel essentially is going to tell you what, going to work with whatever type of Android phone you actually happen to be using. It's going to be the interface to the tablet platform. All of the hardware is going to interface through the kernel. On top of the kernel, we have loadable modules. In fact, these would be modules in the Linux environment. Here they're labeled as libraries, modules. It's pretty much the same thing. Loadable support, and believe it or not, we have SQLite. In fact, there's a database that is actually installed as a module or a library that works native to the platform. And we've got the framework for the media support for running MP3 files and movie files and stuff, SSL for security transactions, OpenGL for graphic library interfaces, lib for, let's say, for programming, essentially, programming interface support and drivers, and basic frameworks to support the library interfaces that are installed on top of the kernel. And then we have our Android runtime environment. Think of it more like the JVM if you think of it, in terms of a virtual machine runtime environment that supports the framework. And the runtime environment, actually, believe it or not, runs below the framework. And the framework is going to be integrated in terms of, and we talk directly to the framework when we write applications. So the Android runtime is going to have our core libraries in it, our virtual machine that we're going to be looking at. And think of this like the JVM. So when we write a Java program, we don't write it for the JVM, compile it like we would on a Windows or a Mac. Instead, what we do is we compile it with the Android Foundation, with the framework, so that we can use the runtime that's installed on the phone. on the Android phone. So it's just a different swap one and JVM out for another, essentially. And then moving right up the hierarchy into our application framework, these are all the components and pieces that we're going to be using in our applications. So we create instances of objects that work with the activity manager, and I'll talk about that for a few minutes. The window manager, content providers, all of the different resources that are available on the phone through the library interface, through that hierarchy, is all going to be used in our applications that we're creating. So most of, 80% of this Android development stuff is figuring out how to use the content provider. And how do you make an object of the content provider? How do you make an object of location manager? Because I want to use the GPS feature that's down here. That's going to give me access to that hardware that's on the phone. That's going to give me my location or something. And the notification manager. That's what puts those little notifications at the top of the phone and uses the notification features. So in our application level, we can get at other applications that are running, interface, multitask between different applications, but we can also go through the framework, and this is the heart of the course actually, is using the application framework to develop applications. And you'll see it's just a matter of making an instance of a framework object and calling to the object and reading and writing back and forth and exchanging information. But I really like this slide because not only is it colorful, but it does give you the entire breakdown of the entire platform. So the next couple of slides are going to go through each one of those layers, but I've pretty much already given you the overview. So let's see if I missed anything. In terms of the kernel layer, it does work as a how. It has device drivers at its part, memory management, process management, networking. Think of this just like any other ordinary kernel in a Linux platform. It has all of the responsibilities of the regular kernel. In terms of the libraries, there is C or C++ support in libraries actually on the Android phone. Most of your development work is going to be done in Java. The interface is done through Java. But a lot of libraries are actually written in C, which is interesting. And there's C components. You can actually program in C on this Android phone as well. Nobody does it because it's not native. In fact, anything you write is going to run slower from an application perspective. But it can be done actually. We have the Surface Manager handling the UI windows, the 2D to 3D graphics. This is where the OpenGL would come into place in terms of those libraries. And you have OpenGL libraries installed on the phone by default. In fact, the entire platform uses OpenGL in terms of its graphic support for 2D or for 3D. Media codexes, SQLite, browser engine, all sorts of different features that would be supported from that particular level. And then, as I was mentioning before, the runtime environment is very similar to the JVM. So the Zarvix VM virtual machine, we have the DEX files, compact, efficient, more efficient than class files. In fact, when you compile using the Eclipse tool that we're going to be using, it looks just like you're creating .class files, but you're not. You're creating, especially if you're importing and you're using the Android platform tools, you're creating a different type of file, but it's equivalent to the class file. It's the compiled version, but it's this platform specific. So it's going to be running on this JVM instead of the normal JVM. So, limited memory and battery power, of course, so we need to optimize. And the class files are pretty much optimized for this phone environment. Core libraries, that might be a little outdated. I think we're up to 6 now, I don't know. Java 5 Standard Edition. Well, the Java versions change, and the support actually changes as Java grows, and the APIs change as new Android toolsets become available practically every couple months. So, in terms of the application framework, this is where we have our application programming interface. As I mentioned before, our activity manager manages the application lifecycle. So the activity manager is sort of like that runtime manager, I should say, that knows what's running and can multitask between the different applications that are running, so you can have things work together, essentially. In terms of the applications, we have some that are built-in and some that are user apps. Obviously, for this class, we'll be making user apps. You can replace built-in apps with your own apps. In fact, you can create a new, let's say, for example, phone app to dial. to dial numbers and stuff if you wanted to. So you can actually customize, extend, modify, essentially, customize, modify the operating environment. So let's take a few moments, and this is probably the most interesting part of this lecture, actually, would be what's referred to as the application building blocks, because this is what we're going to be using in the class. And what we're looking at are about 4 different categories, starting with activity. And if you look at the Hello World number 1, first assignment actually deals with the concept of the activity. And what is the activity? It's a building block, it's a component of the application framework, the layers I just showed you a few minutes ago, that deals with the concept of user interface, I/O, functionality in terms of running program, application, and activity. So the second programming assignment for this course will deal with intent receivers, intent providers, and we'll look at services and then content providers as well. So each one of these building blocks in terms of the application are going to be implemented by you in one of the programming assignments 1 through 5. The first one being the activity, because the activity is kind of the core, basic, easy to understand building block in terms of the application development. So what are activities? Well, typically corresponds to one of the UI screens. So if we create an activity and we attach it and we create functionality through the UI, we might have a button, we might have an input box, we might have, I don't know, clickable something on the screen. And the activity is essentially the user interface in terms of the event-driven programming that's going on. So if you can if you're familiar with the concept of event-driven programming, you're halfway there. And if you take event-driven programming, add it with UI components, and build a framework around it, then you've got activities, essentially. They can also be faceless. You don't have to be tied. The activity does not need to be tied with a user interface. As an example, there might be an activity that works with the notifications, that goes out and checks to see, do I have any messages from my custom-built text messaging program, and then send a notification, which would be creating kind of a communication between your app and the notification module component and this activity that's going on. So we use the pieces and the components in unison, and generally we're going to be using more than one component for the app that we're creating. It might be in a floating window, it might not be, and it could return a value, it could return some information like an activity that goes out and says, how many new messages do I have? It comes back with 5 or something. Or find me a parking space in this parking lot. And it goes out and takes the GPS and all the sensors of all the open spaces that are available, perhaps, if you've got this set up. And it comes back and says 2 or none or something. So that was the activity components or module. Intent receivers is another separate component that works with this interface. So components that respond to broadcast intents. So it's a way to respond to external notifications or alarms. As an example, you might have a notification that comes through, and if you're not familiar with an Android phone, don't worry about it. You'll pick up the jargon as we go through. But it's really hard to find a CS student who hasn't heard of Android at this point. But if you notice there's some notifications that are up there, when a notification occurs, you might have an intent receiver that takes and does something, opens up a window, provides some sort of functionality to that particular event that occurred. Apps can invent and broadcast their own intents. So you can create an intent and use it from a user-specific type of activity or behavior that goes on for your app. So maybe your app is a grocery list or something, and you want to advertise. Every time you purchase something and you've updated it, it'll update the list. You've got some notification that comes out and says, hey, remember to get this, remember to get that. You still have to get this or something. Or, So intents. Think of intents as a verb or an object, and a verb and an object, excuse me, a description of what we want done. View, call, play, run. It's activity. So an intent might be fetch this, find that, view the new messages that have come through, automatically call my email or something, or my voicemail or something. So the system matches the intent with the activity that can best provide the service, hopefully, that's available, perhaps. Activities and intents describe what intents they can service, or what can be done. So usually we have, we're going to start out programming a basic activity, which is going to be our hello world activity. In fact, our hello world is going to actually have a couple of components on it. The first assignment is actually more than just your regular old, hello world. Instead, it's going to have an input box where you can put a name in there and a button. And we're going to connect the components and make it functional, essentially. And then, so we can demonstrate the activity part of it. In fact, we're also going to use an intent in that first example as well. And the intent is going to be the call, essentially. And it's going to be taking the name that we've typed in the text box and sending it to this other component. So you can kind of think of intents as communication channels, kind of. So that's how the verb kind of mixes in, along with an object at the same time. So once it's sending a message, the message is the message. And the communication between the two windows or between the application itself would be an activity in terms of the components. So there's another example here of intents and how they work. And so let's say we've got the system picks the best component, that particular application that's going to be used. And as an example, if you're in Gmail and you're going to pick a photo, click on the component that makes a request for a specific action to occur, and the photo might bring up the photo gallery. So intents, if you think of it more along the lines of communication, sort of. If I wanted to, if I were working on my computer and I wanted to add a file to a zipped file, like I wanted to compress and create a zip file, the intent would show me all the available files that were on the system that I might want to add. So when you click on a MP3 file, what's going to play the MP3 file? The MP3 program or the application that's on there that knows how to play an MP3 file. So that activity, the intent would go over and open up the MP3 file and open it up in the right application or in the right component that it needed to run in. Same thing with picture viewers, email, chat stuff. So that's why I keep calling them communication channels, sort of. But they're really called intents. And the purpose is essentially to form that connection in terms of the components. So new components can use existing functionality that exists. And intents allow us, for example, to create an application that uses GPS services. Or that uses the contact list, uses the phone book, or something. So we can connect to components that we don't own, but we're using it in our application. We're going to use built-in components that exist on the platform. So activities, intents, intent receivers, and then we got services. Services, faceless components that run in the background. You guys are all Windows users. I know this for sure, because when I said I didn't like Windows, I saw a lot of sad faces. So if you think of the Microsoft Windows services, you got it down. If you're not a Windows person and you heard services, first thing I think of is background threads. Foreground, background. Services are background threads, or they're services in terms of the same definition you get in Windows. Faceless components, because they don't have, that's where they're background. They don't have a foreground interface to them. They run in the background, they play music, they do network stuff, they download stuff. We can create a program that uses services, that runs on our phone, kind of like a nasty virus that every 10 minutes reminds you that you have to go to work, or something, that doesn't really have an interface to it, but maybe it sends you nasty text messages or something, or maybe it sends little pictures or something, or does something. So we're going to look at services in one of the programming assignments. I believe it's going to be around 3 or 4, number 3 or 4, homework assignment. Where we'll create a service, and I believe the service is probably going to be using the GPS features or something. So it's not going to be doing a nasty virus. So content providers enable sharing of data across applications. So a content provider, if I were in my email program and I wanted a picture, I would probably want to pull it from the photo gallery, and that's what basically this is using intents using content providers. So as an example, we're going to use both concepts together. We have created content intent, we also create what's called a content provider object. We ask the object to go into the photo gallery, go into our MP3 files, or music selection, or go into our web content, and pull something out and use something, or contact list. The program that we're going to write in this class is going to use a content provider to use the address book. So you have some addresses in there, and we want to send an email to, let's say, someone in our address book. So it could automatically, let's say, for example, pull up a list of those people. So you could just select, oh, this person, that person, kind of thing. I can't remember, but I don't believe our app's going to do that. But that would be very simple. In fact, that might be easier than what your app's going to do. But long story short, it allows you to share data among different types of applications. Provides a uniform API for querying, deleting, updating, inserting, managing the data that's on the phone. You can also use a content provider to connect to databases, the app market, to find out, well, what apps are available by this particular name, or database content that might actually be stored on your phone, because your phone actually has a database on there as well. So, and we will definitely be writing a program that works with a database that's on the phone. So content is represented by a URI, or a MIME type, in terms of the content type. And what I just did a few minutes ago is I went through this list here in terms of activity, intent receiver, service, and content provider, which is the basic foundation or the building block for the development environment that works with this framework. It works with, in fact, what we're looking at is components in terms of the application framework that we're using when we're creating these applications. So it's going to interface with the libraries that are available on the phone, which is the most foundational building block possible in terms of the Android platform. The next part goes into the concept of the development tools, and I kind of briefly mentioned this already, and this is kind of like why today's class is going to be on the short side, is because we don't have anything to work with yet. So what you're going to do is you're going to be installing Eclipse, and if you missed the first part of this lecture, I went through the different platforms that were available, and I have YouTube videos created for Linux, Ubuntu. I wouldn't call it just generic Linux, although if you can install it on Ubuntu, you can install it on almost any Linux breed out there. The Mac, the Windows system, the Android 2.0 or higher. So I don't think you're going to get 2.0 right now. I think we're up to 3 or something like that right now. But you'll be able to, and maybe when I'm done here, I can bring it up. I can kind of show you what we're looking at in terms of the APIs. You don't have to install every one of the APIs. You only have to install one, whichever one you want to use. I would actually use the most current one, however, because some of the syntax for some of the examples you might see are going to be backward compatible, but they may not be forward compatible. So, the emulator comes along with the API, and we can write in the development toolkit. You say run this program, and it brings up the emulator for us. And the emulator is going to be a fully functioning phone, which is why you don't need to buy a phone. You don't need to have a phone. If you don't have a phone, don't worry about it. This is an old picture of an old phone. ARM emulator runs the same image as the device. No camera support. Actually, believe it or not, I think I heard a couple rumors that they're adding camera support, actually. So, in fact, you can actually open up a web browser in this thing too. For those of you who have never seen it, at the end when I get done with this PowerPoint part, I'll bring up the emulator and you can actually kind of see it. So you know what your tools are at least. The devices, yeah, any device. I believe that kind of looks like a Droid X sort of, but not really. That's an older, these are all older phones. So, hello world. So to get started, in fact, actually to get started is quite easy. You don't even have to do anything. You just have to make a default project. And maybe I'll just do that at the end to kind of show you. But it's just like most of the development tools these days. As long as you can create a default project and hit run, it'll go ahead and run it in the emulator for you, and you can actually kind of see it work without actually knowing anything about programming, essentially. But the first thing you're going to want to do, if you're advantageous, is to go, and this link actually works. I tried it the other day, so I know it's current. The Android development, developer.android.com, and I'll bring up that website too as well, is the most feature-rich website in terms of development tool and support I've ever seen. There's applications for everything. In fact, a lot of my assignments are using tools and things that you'll have to get from this website. and the link will be provided for you. But it is very helpful, you know, not to compare it to Microsoft again, but it's nothing like the MSDN library stuff. This is actually quite easy to follow, has tutorials and has information on it that is actually useful. So, generating UIs, looking at the building blocks, using at text view, text edit buttons, placed in layouts and linear and table layouts and absolute layouts. And that is the purpose of the first homework assignment, actually, is to get familiar with the components and the pieces of the UI so you know what you're working with. We also will be familiar with the application life cycle, which is the starting and the ending of the application. So the application itself that runs in its own process. And this is when it goes back to the Linux kind of environment. We are working with a Linux system. Every program that runs, well, just like Windows, every program that runs creates a brand new process and runs in its own process space. So processes are started and stopped. So they needed to run the application and the components themselves. And they can be killed to reclaim resources and things as well. So this is an important slide, actually. And you know what? If I were you, maybe I'll do that. I think I'll take this slide and put it in a separate document, in a Word document, and make it available on the website. Because this, believe it or not, is the life cycle of the running application. Just from the beginning, what we're going to see in Hello World comes through onCreate and onStart methods. The thing is when you create, well, you get the default stuff. When you create a blanket, you know, just a plain old application in Eclipse, you'll get fake methods, you know, they're called dummy methods, you know, that get loaded up. And especially when you import a new component, you'll see something appear and it'll be onCreate, onStart. And you know, it's like it takes a long time to actually kind of get familiar with, well, what do these components mean? Go back to your first day, your first programming class for C, and they said, well, here's main, and people looked at, what do you mean by main? All the thread of execution for the entire program starts right here in main, and you have to have a main function, and you know, in the format for how the C program ran. And then you learn Java, and they said, well, you have to create a class, and the class starts here. Oh yes, by the way, you have main, and that's going to be in your driver class. And you have all these other classes that can be called from this class. Well, on your first day of Android, I'm going to tell you, onCreate is when your program actually starts. It's sort of like main. So, on the creation of the app, then on the start of the services of the app, and then we have the entire cycle, and this is what we're going to be looking at in terms of the Hello World. And this is why the Hello World tutorial is so important, because it kind of gets you familiar with the different execution order, how the app actually starts, and what's created, how the functionality begins with. And if you notice the flow chart, and this kind of looks like a flow chart, the activity starts, and then the onCreate starts, and then the onStart. Like after the activity is created and the activity thread is running, we're starting the application, and then we have a run. And then we have, what if we pause and we have an on resume? What if we come back to the app? What if the app's running and we go to something else and we resume? And the behavior of the activity that is running. And then another activity that comes in front of the activity. We might have a pause that occurs on our activity. And then we might have a stop when the activity is no longer visible. And then we have a destroy. And this is where we're doing our garbage collection and our cleanup. And our stop and our destroy. Then the activity is shut down, and in between we have these side components that are working. As an example, on a start, another application needs memory, so we're going to pause temporarily so we can let another application run. And then maybe the process is killed, and we use we navigate back to our application and we create it again. If you've ever noticed that, it actually does happen with a lot of apps. You're running an app, the app goes and runs something else. 5 minutes later, you go back to the app. Oh, starts fresh, brand new again. I thought that was running. Well, it was running now. We started it again because the app was smart enough to figure out that it needed to go to sleep. It needed to it needed to give back its resources. It was paused for too long. It timed out. Then it started back up again. So we're looking at a lot more sophisticated environment, long story short, than running an application on a computer. When we just start a process, the process runs. Actually, in a Linux box, or a Windows box, process can just run indefinitely. It's on an island of its own running. We got a lot more communication in terms of the coordination between the framework and the app in the Android world. So Android's not really, the app is not running in a world of its own. It's actually, there's a lot more networking going on, a lot more communication with the resources, with the phone itself, the overlying framework. So if the activity comes to the foreground from a pause, it can come back to a resume, and the activity comes to the foreground, goes back to a non-start. So I think I will actually make a separate Word doc, because eventually, lo and behold, after about the first application, maybe even after you write your first application and you're working on your second application, you're going to want to go back to this flow chart, because then you know what methods you need. Why isn't something loading correctly? What's happening? Why do I need to do an on resume? You know, and these are just blanket methods that appear in your source code, and you'll see, you know, when you start looking at this long enough, you'll see all these methods in your project, and then hopefully you'll get a better understanding. And I'll be going through that throughout the entire course as well. What goes in this method? What goes in that method? How do we program that correctly? So in terms of the life cycle, we got a little picture here. We got system processes that occur, and we all know about home. So we have home, mail, browser. These are different system processes, and then from our home context, Gmail is an example, we're loading up and using different apps associated with different functionality, with different services that are running. And we're switching back and forth, which is why we have resuming and pausing, and we have all the different states as you see in this diagram here. Because they're not all just running on an island of its own. It's a separated, isolated thread. So there's a lot of thread communication between the apps. In terms of the location manager, this is where we're going to find our GPS location, and I have an entire lecture on GPS that we're going to use to create an application in this particular class. So, XMPP Services allows any app to send a device-to-device message to other Android users. So we'll take a look at that as well. That's still supported. It's actually kind of an old feature. Hardly ever used very much, though. But there are some uses for it, and we'll see that later on in the course. Data messages are intents with name and value pairs. Works with Gmail accounts, can also build servers to deliver server-to-device messages and stuff, broadcast messages from servers to phones. So doing device-to-device communication, sending messages back and forth. Notification manager, as I mentioned before, it's that little thing at the top of the screen. If you don't have a Google phone, you know, I was going to do that to the monitor, but you can't see that. I'll do it to the, you go like this. You take one or two fingers and you drag the top of the screen down, and you see the notifications. I believe that's, well, this one has a little clear button in it. That's like the old-fashioned kind of way. I believe there's different spaces you could put that in now. I don't know. But, the classic approach was to put it at the top of the screen and you pulled it down. You can write your own applications that sends your own notifications. So you can have like reminder messages and stuff that come up. You know, hey, pick up the milk or whatever. Pick up this. Well, you have school today. You know, you can make your own notifications that go off throughout the day if you wanted to. Actually, that's an extremely easy application you can build in 5 minutes probably. That you can create. Notification managers, how background apps interact with the users. We have managers out there that send and receive and deal with notifications. So how apps actually interact with the users to send the user something, a piece of information. Consistent notification presentation is through the notification manager, and this would be referred to as the manager, notification manager. It's that little functionality in the interface, in the framework, that allows you to stick stuff there. It's kind of like how Windows has a desktop, or actually every operating system that has a desktop. GUI has a desktop concept where you can stick icons out there, sort of like notifications. You have desktop managers, notification managers. So we have different views, and we'll see this actually. In fact, this looks very similar to our Hello World that we're going to build on our first program for this course. But we have an example. This is a linear layout. This is a grid view where we have kind of a grid of components that we can populate with different pictures or music songs or something. This linear is going line by line. This one here is going to be a form view. Form view is probably the more popular view for user input and stuff. It's kind of like kind of a cross between application development and website development, if you think about it. When you display components on the canvas, the screen, it's kind of like your web presentation. And the interesting thing is this is done in XML, so the entire interface is XML. It's not HTML, but very similar. XML is a kind of a data tagging rather than markup language. HTML is used to like change the font color and stuff like that. XML is used to say this is the input field. That's the checkbox. That's to actually put these data components on the screen as they occur. We have this is the relative layout that's going to essentially format things as relatively associated with other items on the screen. This is a list view. We're going to be using the list view. This comes in very handy with, let's say, for example, database access, content provider access, where we have an entire list of results, a result set that comes back. It's easy to put it into what's called a list view. These are separate, this is going to be a web view. It's going to give us a web interface connectivity. So, a long story short, what this is doing is it's overviewing the UI interface tools. This takes seconds to put together, actually. It's not labor intensive. So it's kind of like, if you're ever familiar with Visual Basic or ASP.NET, it's kind of easy in that it's a drag and drop. Stick some stuff onto a canvas. The hard part is programming the functionality for the widgets that you have stuck on the canvas. And I wouldn't say that's hard. It's just basically remembering what name you gave it and telling the name that on a click, do this. On a change, do that, and stuff like that. So that's what's referred to as event-driven programming. Here's an example of the location manager, which finds us on a map. It says this is our location. Believe it or not, this works on the emulator. It will work on your emulator, which is kind of interesting. So it'll actually use the Google Internet location. So you don't actually have to have a GPS device on your computer. It will use your internet access. If you have internet access, it will find your current location on the map. Good. And we're going to create an application in class, one of the lectures. I'm going to actually do a GPS application for you that will tell you where you're at and where you need to go, kind of like a mapping thing. So first task, and I'm not going to end exactly after this PowerPoint. What I'm going to do is kind of bring up Eclipse and kind of show you the emulator. For those of you who have never seen it before. But in terms of our objective for next week, and the reason why this week is just kind of a simple PowerPoint is I can't do anything unless you actually know what I'm talking about. So it's not a bad idea to install the SDK and Eclipse and install Java and look at assignment number 1. It's a great way to get your first programming assignment out of the way. It's the easiest assignment of them all. And I'm not going to actually perform it in class as the slide says will be performed in class as well. Instead, I've done something else for you. This is what I've done for you. And for those of you who are here for the introduction part, I showed this to you, but I'll just kind of reiterate the point again. If you go into the Android phone application development link on my website, and you go down to the video lectures, you'll see the install videos. You'll also see this one here. This one here will take you to the video that is going to go over assignment number 1. And let me mute this because it's going to start up. There we go, stop it. That might look familiar, project 1. It's actually going over assignment number 1. So it's going to show you what to do. So you'll get your first assignment out of the way. And the reason why I'm making this easy is because I'd like you to get your first assignment out of the way. Because if you do that, then I know when I'm talking to you actually are understanding what I'm saying. It's hard to go through the entire course and wait till the last week to do the assignments. Because you're not going to get anything out of the class. Because you're not going to understand what I'm talking about. And it's like, why show up if that's the case? I think so. That's why it's like encouraging to hopefully, and you don't have to get it done for next week. You could just start on it. And the first couple weeks is kind of like the ramp up time. So next week I will be running through an Android application. Just so you're familiar with what I'm talking about in terms of the tool set. This is what Eclipse. I have just clicked on Eclipse. Indigo. And if you have Helios, if you have one of the other versions of it, that's fine. It don't really matter. I don't really care which version of Eclipse you're using. They're all supported. But I believe Indigo as of maybe December, Indigo was the was the most current one. I just reset all of these tools kits actually in December last month. So. It does take a few minutes actually to load up, which it's doing right now. You can kind of see the status bar here. When you've installed, and this is free. Oh, look at that! I have Hello World on here already. Lab number 1. If I run this, this is what the emulator is going to look like actually. Oops. Let me run Hello World. Actually, here, let me do something else for you. After you've got your tool set installed, go up and just select a new project. And after you've got your tool set installed, this is how you know you have it installed correctly actually. In your window, if you have Android SDK Manager, ABD Man, these are the Android tools. If you don't have this in your window directory, you don't have it. If you've just installed Eclipse, you don't have it. You've got to go through the instructions, download the Android API, and then come into the Eclipse system and add Android to Eclipse, which is the key, so it's all together in one. If you do have that, if you go New and you go Project, you can select here, make this bigger so you can see, you can select Android Project. An Android project is going to create an Hello World for you. It's not going to be the same Hello World that assignment number 1 is going to create. I'm just going to call this Hello. And here's the other interesting thing as well. So for the purposes of the assignments for your course, and now we're up to, I believe the slide set said Android 2.0, which is not even on my list here. I didn't go back that far. Android 4.0. This is about maybe 3 or 4 months old. Maybe not actually. I think it came out in November. I installed this in December. So, long story short, 4.0 already, which means if you are using 3.0, that's fine. Your emulator is going to look slightly different than mine. Most of everything is going to compile correctly because a lot of the libraries and packages I'm going to be talking about are basic standard stuff. They're not going to be anything particular 4.0. Only problem is, if you go online, you find an example, you find a sample project, and it's using 3.0, you got to use the 3.0 API. If it's using 4.0, you actually have to use the 4.0 emulator and the API. Otherwise, it's not going to compile correctly. So that's why I have all this stuff installed here. And if you've just installed 4, you're just going to have 4. If you don't go back, and it's kind of easy. From the video will walk you through it. I would personally spend the hour, install everything. It's not going to take up that much extra room on your hard drive, but it's going to give you the ability to quickly, without having, oh, I have to install 3.1 now, without having to go back and install the API. You already have the API. So you can download the projects that you find that works with 3.1. You can run it without having to worry about it. You can create emulators for all of it. So if I'm just going to quickly just kind of run through this just to show you what the emulator looks like. And I'm not going to run through what I'm doing right now. I'm just going to set up the project. So, if I set the project up, I removed my screen, it looks like. So let me make this smaller so I can see what I'm doing. Where's my window? Well, my package window is missing because I removed it. Oops. And hold on one second. Well, you can't see my files because I've removed the screen. I'm trying to figure out how to get it back. Let's see, window. Console window. Got that one back. So the package window. Package Explorer. Here we go. That's the Package Explorer. You know, the problem is I went through and I started clicking and I closed everything. But this is the window I wanted right here. If I look at it, this is the one I just created. And you can see the files that were created in here. If I run it, all I have to do is right mouse click on it and go to Run As. And I have these choices here that appear on the bottom of the screen. An Android application and stuff. When you select the Android application option, it will bring up the emulator for you automatically. The other way of doing it is to actually go to the Run menu and say Run As Android application. And if I do that, what I'm going to get is an emulator that's going to show up eventually here. Here it is. It's in the background now. So this is for those people who have never seen this before. This is what the Android development environment is going to give you. Eventually, this is going to, here it comes. So you actually have to be sort of patient with this as well. This screen comes up, and then in a few minutes you'll see a phone screen come up, and you'll be able to navigate it just as if it were a phone. So the emulator is quite feature-rich. My only complaint with this one, the Android emulator, is it runs on the slow side. So, and it has nothing to do with the computer, actually. I've tried it on practically every platform I could possibly imagine. I've done it on Linux, Windows, Mac. I've done it on a completely fresh system. It had nothing running on it. It still runs the same way. So, well, because it's loading up an operating system on top of an operating system. You know, imagine how long it takes to load an operating system. And that's what's going on. If you haven't seen it yet, the iPhone emulator runs in a similar way, but it's a lot faster. The iPhone emulator will come up within seconds because it's actually not running on a separate emulator. It's an emulator, but it's not running on its own operating system. It's not loading an operating system. So with a little patience, this will actually turn into an Android phone. We're going to see that momentarily. And if you watch the first video, you'll see my frustration in terms of waiting. In fact, I think I even paused the video and I come back. And I say, look, it's running. It started. But this will. I have patience. We're not going anywhere. I'm not going anywhere yet. So. This will load. In the meantime, you can actually still play around with Eclipse, and you can still be editing your program. And there's a little window here that can show up. In fact, let's see. Now, I was going to say I can put the window back, but you can navigate. In fact, this is probably one of the things you want to do is kind of go through and get familiar with the menu items. Most of the items that are up here are also available through the right mouse click of the button. So it depends on, let me check my emulator. My emulator is still loading. It depends on, I'm waiting for the emulator to load, so I'm killing time right now. It depends on your preferences, whether or not you like to use the mouse or whether you like to use menu items. So. Let's see, navigator, search, task list, distraction. Yeah, if you load up the progress button, you'll see, oh, here we go. It did finish. I'm like, it says it's done. It did finish. So if I drag this to the unlock, imagine putting your finger on here. You have to actually do it with your mouse. If I unlock this phone here, wait for it to run. Wait, it has the date correct. This is Monday, January 23rd, but why does this say 50%? It has the time actually correct as well. And I clicked too many times. I have to let this wait for a few minutes. This is the expected results, however, so just be patient with it. Here we go. The launcher is not responding. Would you like to close it? Yes, let's just close it. There we go. Now if I click on here, and the launcher was supposed to run my Hello World application, and I believe what happened is I clicked too many times, so I wasn't patient enough. I am now clicking to get into the application menu so I can kind of see what's on here and show you that the web browser actually works and stuff. We appear to be a little bit memory challenged or something going on here, but we'll see. Actually, I have found, believe it or not, the Windows emulator running in the Windows window on top in a parallel screen actually runs faster than the emulator running on the native Mac, which is kind of interesting. So here's my Hello World application here. Did I call it Hello? No, I think I called it Hello. No, this is a different Hello World app that I had on there. So if I click on the menu button, it'll show up the drop-down menu. But I don't have a drop-down menu for this, so I'm going to click on Home. Go back home. But you can see, as an example here, oops, I go back to browser. This should bring up a web browser, and it should give me along with the internet connectivity, like the web browser. I have an internet connection right now, so although it's not the most preferred way to run your web browser, because this is going to run like a snail, but and unfortunately, I have to learn how to be patient. Every time I click on something, it messes everything up. So I'm just going to take my hand away from the mouse. Just wait for this thing to load. But if I search on something, and you can use the keyboard. Yep, here we go. If I go, so you can see how slow. There we go. It should actually bring up search results. I don't have too much patience. When this is finished, I'm going to end this. This is painful. That is the part that I don't like. Although the programming is easier, it's all done in Java. This emulator is painful. There we go. I just want to make sure this thing works in terms of connectivity. Yeah, it does. Look at that. So I brought up search results that are associated with it. So if I actually clicked on, it's going to be even more painful to watch. If I click on it, it will hopefully bring up my website in 5 or 10 minutes. Obviously, however, if you have a Google phone for this course, if you load the app on your phone, it'll run lickety-split, just like any other app. It's just the emulator that runs like this. And I'm not quite sure why they haven't changed it. I mean, I'm not quite sure why they haven't optimized this a little bit more. There are some, if you go out on a website, if you go out on the internet and search for a little bit, you'll see some optimization techniques. You can save images, you can cache certain things on in the emulator itself. Oh, look, it does work. Okay, good. You can load it in a ARM emulator, run it in different modes, and play around. I've done most of that stuff, and it hasn't made that significant of a difference on my computer. So, but you're more than welcome to experiment with that. But that is a preview of the development environment, which is what you're going to get on the first day of class here, to what it is that you've signed up for. So my advice is to go home, install the development toolkit, and run through if you can. If you can get the development toolkit installed, great. Bring your computer next week. We'll be going through our first app in class. If you can get as far as a hello world, you've outdone yourself. You can do that next week if you want. You don't have to do that the first week. If you don't do anything, then you gotta probably gonna be bored next week. Let me sit here. But, questions, comments, concerns? Yes. Yeah. Oh yeah. That's what I was saying. If you have Helios, you can use that. This is Indigo. If you go on the website here, actually, if you go out onto the Eclipse website, see, this web browser goes a lot faster. I can't remember the Eclipse, actually, unless I have a bookmark here. I don't. The interesting thing about Eclipse, and this is kind of I shouldn't call it a pain, eclipse.org. Download Eclipse. Is you've got all these different versions, and you've got the EE version, you've got in fact, if you've got the EE version, here's the interesting thing about Eclipse, as long as you've got one that supports Java, you can install the Android toolkits into it. It doesn't matter what version of it. If you have Helios, this happens to be Indigo here. You can go back and get other versions of it by clicking on the other versions. If you already have it, if you have a Helios version, which you might have, it sounds like you do, go ahead and use that and install the Android stuff into it. That way you don't mess up anything else that you might have installed in it already. So it's not an all or nothing. You can install other stuff into it, which is great. The only issue that you might run into is if you've got one for C++ and you don't have the Java version of it, then you might end up having to reinstall it and make sure you get both Java and C++ in the supported base Eclipse package, and then install Android tools. So I guarantee it though, if you run through the video, you run through the instructions, you'll get it installed on the first try. The only problem is make sure you have a fast internet connection. The Android stuff takes, if you do all of the packages, all of the lower APIs, which I highly recommend, it's going to take you an hour to 2 hours. Yeah, on a regular old DSL connection. It's a lot of download stuff. That and the server runs on the slow side a little bit. So, plus it's got a download configure. It does it all in one shot kind of thing, so it does take a long time. But who knows, I might have a slow connection, your connection might run faster. Worst case scenario is going to take you about an hour or something like that. So don't do it on your lunch break. Do it like, after work. You have some time to sit there and watch it. So, that was a good question. Any other questions? No, then we're done for today. Thank you. Next week, we will start doing Android application development. Hands-on.